18.3.2 Cardiac cycle. How does the heart function? Let us take a look. To begin with, all the four chambers of heart are in relaxed state. That is, they are in joint diastole. As the tricuspid and bicuspid valves are open, blood from pulmonary veins and vena cava flows into the left and the right ventricle, respectively, through the left and the right atria. The semilunar valves are closed at this stage. The SAN now generates an action potential which stimulates both the atria to undergo a simultaneous contraction, the atrial systole. This increases the flow of blood into the ventricles about 30%. The action potential is conducted to the ventricular side by the AVN and AV bundle, from where the bundle of His transmits it through the entire ventricular musculature. This causes the ventricular muscle to contract, ventricular systole. The atria undergo relaxation, diastole, coinciding with the ventricular systole. Ventricular systole increases the ventricular pressure, causing the closure of tricuspid and bicuspid valves due to attempted backflow of blood into the atria. As the ventricular pressure increases further, the semilunar valves guarding the pulmonary artery right side and the aorta left side are forced open, allowing the blood in the ventricle to flow through these vessels into the circulatory pathways. The ventricles now relax, ventricular diastole, and the ventricular pressure falls, causing the closure of semilunar valves, which prevent the backflow of blood into the ventricles. As the ventricular pressure declines further, the tricuspid and bicuspid valves are pushed open by the pressure in the atria exerted by the blood which was being emptied into them by the veins. The blood now once again moves freely to the ventricles. The ventricles and the atria are now again in relaxed diastole state as earlier. Soon the SAN generates a new action potential and the event described above are repeated in the sequence and the process continues. This sequential event in the heart, which is cyclically repeated, is called the cardiac cycle, and it consists of systole and diastole of both the atria and ventricle. As mentioned earlier, the heart beats 72 times per minute. That is, that many cardiac cycles are performed per minute. From this, it could be deduced that the duration of a cardiac cycle is 0.8 seconds. During a cardiac cycle, each ventricle pumps out approximately 70 ml of blood, which is called the stroke volume. The stroke volume multiplied by the heart rate, number of beats per minute, gives the cardiac output. Therefore, the cardiac output can be defined as the volume of blood pumped out by each ventricle per minute and averages 5000 ml or 5 liters in a healthy individual. The body has the ability to alter the stroke volume as well as the heart rate and thereby the cardiac output. For example, the cardiac output of an athlete will be much higher than that of an ordinary man. During each cardiac cycle, two prominent sounds are produced which can be easily heard through a stethoscope. The first heart sound, lub, is associated with the closure of tricuspid and bicuspid valves, whereas the second heart sound, dub, is associated with the closure of the semilunar valve. These sounds are of clinical diagnostic significance. 18.3.3 Electrocardiograph ECG. You are probably familiar with this scene from a typical hospital television show. A patient is hooked up to a monitoring machine that shows voltage traces on a screen and makes the sound beep 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 as the patient goes into a cardiac arrest. This type of machine, electrocardiograph, is used to obtain an electrocardiogram ECG. ECG is a graphical representation of the electrical activity of the heart during a cardiac cycle. To obtain a standard ECG, as shown in the figure 18.3, a patient is connected to the machine with three electrical leads, one to each wrist and to the left ankle, that continuously monitor the heart activity. For a detailed evaluation of the heart's function, multiple leads are attached to the chest region. Here, we will talk only about a standard ECG. Each peak in the ECG is identified with a letter from P to T that corresponds to a specific electrical activity of the heart. The P wave represents the electrical excitation or depolarization of the atria, which leads to the contraction of both the atria. The QRS complex represents the depolarization of the ventricle, which initiates the ventricular contraction. The contraction starts shortly after Q and marks the beginning of the systole. The T wave represents the return of the ventricle from excited to normal state, repolarization. The end of the T wave marks the end of systole. Obviously, by counting the number of QRS complexes that occur in the given time period, one can determine the heartbeat rate of an individual. Since the ECGs obtained from different individuals have roughly the same shape for a given lead configuration, any deviation from this shape indicates a possible abnormality or disease. Hence, it is of a great clinical significance.